Hello, grade 12s. Hopefully you are doing good. I want us to discuss two questions on your investigation. I believe it's question 4.1 and 4.2. Let me share the screen so that we can go and look at the questions that I'm talking about from your investigation grade 12 2025. I want to get the question paper. Yes. Okay, great. We are getting the question paper for your investigation 2025, term 1. So I want us to go and look question 4.1 and 4.2 because I've been receiving a lot of questions regarding these two questions, 4.1 and 4.2. So without waste of time, let's look at these two questions. Okay, the first question, which is 4.1, we are required to prove the identity. We are required to prove the identity. When you are proving the identity, always start with the complicated side. So I'm going to start with my left-hand side, which is the complicated side. I'll say my left-hand side, which is 1 minus cos 2a over sine 2a. Now, how do we solve this problem? 1 minus cos 2a over sine 2a. We notice that cos 2a there, it's what we call a double angle. This is the topic of trigonometry. Cos 2a is a double angle. So cos 2a, it is equivalent to these three things that I'm going to write here. Cos 2a, it's equivalent to 1, it's equivalent to cos squared x minus sine squared x. Sorry guys, someone is calling me. Just bear with me for a few. I have to take it, guys. You never know. Oh, the person stopped calling. Askis. Okay, I was saying cos 2a, it's equivalent to cos squared x minus sine squared x. And it is also equivalent to 2 cos squared x minus 1. And it is also equivalent to 1 minus 2 sine squared. Or let me use a instead of x. A 1 1 minus 2 sine squared a. Cos 2a is equivalent to these three things. Cos squared a minus sine squared a. It is also equivalent to 2 cos squared a minus 1. It is also equivalent to 1 minus 2 sine squared a. Cos 2a is equals to this three expression that I gave you. I wrote number 1, number 2, number 3. So, and this is also there on the grade 12 maths formula sheet. Cos 2a, it's equivalent to cos squared a minus sine squared a. It's equivalent to 2 cos squared a minus 1. It is equivalent to 1 minus 2 sine squared a. It's equivalent to this free expression. So in this case, I'm going to substitute this cos 2a here with one of those three expression. So I'm going to say 1 minus. In this case, I'm picking number 2. Remember, I wrote 1, 2, 3. So I'm picking number 2. I'm picking this one. I'm picking 2 cos squared a minus 1. This is the one that I'm picking. Cos 2a, I'm saying it's equivalent to 2 cos squared a minus 1. My choice is it's so wrong because I'm going to have a positive answer. If I use this one, I will have a positive answer. I don't want to have, I'm picking the wrong one. Why not I pick 1 minus 2 sine squared A? Let me pick 1 minus 2 sine squared A. I will explain, guys, why I'm picking this one. Let me pick number 3. 1 minus 2 sine squared A. Yes, 1 minus 2 sine squared A over sine 2A. Sine 2A, it's also, sine 2A, it is also the double angle, and sine 2A, it's equals to 2 sine A cos A. We're talking about the double angle identity. So when you see sine 2A, you know that you can substitute it with 2 sine A cos A. I'm saying this again. Sine 2A, we are dealing with trigonometry. This sine 2A is a double angle of sine. It is equivalent to 2 sine A cos A. So you're going to substitute sine 2A with 2 sine A cos A. This is something that you need to know, guys, and it is also there on your formula sheet. Sine 2A can be substituted with 2 sine A cos A. Now, I'm going to apply distributive law. This negative here is going to multiply 1. This negative here is going to multiply this negative. So I'm going to have 1. Negative times 1 is negative 1. Negative 1. Negative times negative is positive, plus 2 sine squared A all over 2 sine A cos A. Now, as we continue with our expression, we know that 1 minus 1 is 0. So the numerator there is this 2 sine squared A, 2 sine squared A over 2 sine A cos A. So we have to continue now simplifying further. We know that this 2 sine squared A is actually the same as 2 sine A times sine A over 2 sine A cos A. 2 sine A cos A. Sine A cancel sine A. 2 cancel 2. So you're left with sine A over cos A. And sine A over cos A, it's what we call the quotient identity. Sine A over cos A is tan A. So sine A over cos A is tan A. So you have solved for the expression. You have proven the identity. 1 minus cos 2A over sine 2A is tan A. So you have to specify, you say, therefore, left hand side equals to right hand side. So when you were proving this identity, what was important, it was the idea of a double angle. You have to know that sine 2A is equals to 2 sine A cos A. That is sine 2A. 2 sine A cos A. Now, cos 2A, you have to know that it can be substituted by any of those three guys. So the question is why? Why did I pick 1 minus 2 sine squared A? I picked 1 minus 2 sine squared A because I knew that 1 minus 1 will give us 0. I wanted to be left with 2 sine squared A on top. So somehow there was supposed to be 1 subtracting 1 so that those ones are no longer there. So when you pick, in this case, if you are having something like 1 minus cos 2a, pick one of those three, but make sure that this one, let me write here, you have got 1 minus cos 2a. Sorry, where I'm writing is not visible. So pick the one pick from these three identities, pick the one which will be able to subtract this one here. So it was 1 minus 2 sine squared a. So we are going to look at now 4.2. We're going to deal with this one of 4.2, which is tan 75 without using a calculator. So I want to solve tan 75 without making use of a calculator. So tan 75, we know that tan 75 is the same as sine 75 over cos 75. This is what we call the quotient identity. So when you have got tan of an angle, let's say you've got tan of theta, you have to know that tan of theta is equivalent to sine of theta over cos of theta. So tan of 75, it is equivalent to sine of 75 over cos of 75. I'm talking about the quotient identity. This is what we call the quotient identity. Tan 75 is the same as sine 75 over cos 75. Now, this angle 75, we are going to express it in terms of what we call spatial angles. In trigonometry, we've got the spatial angles. What are the spatial angles? 30, 45, and 60. These are your spatial angles. So you have to express your angle 75 in terms of the spatial angle. So what are we going to do? We're going to say sine of this 75. We're going to write it in terms of angle 30 plus angle 45. Angle 30 plus angle 45 over even cos 75. We're also going to express it in terms of angle 30 plus 45. So we're going to say cos angle 30 plus angle 45. Because I need enough space, guys, I'm going to continue with this problem here. I'm going to write it here. I'm now going to apply what we call compound angles. I'm going to apply my compound angle. I'm going to apply the compound angle of sine. What you have to know is that if you have got something like sine of angle alpha, angle A plus angle B, sine of angle A plus angle B, you can express this in this manner. You can say sine of angle A plus angle B, it's sine of A. I'm applying compound angle of sine. It is sine of A. You pick your first angle, sine of A times, now you are going to use cos. You are going to involve cos. So in this case, you are going to say cos of this angle here. What is your angle? Angle B. So now you say cos of angle B. Expanding the compound angle of sine should be very simple, guys. You always start with sine. You say sine of your first angle. What is your first angle in the bracket? It is A. Now you multiply by, you are going to involve the trig ratio cos. You involve the trig ratio cos. Which angle are you now using? You are using the second angle. You say B. You say plus, when you are expanding sine, the sign does not change. If it's positive here, you still keep your positive. Now this side, it should be simple what I'm going to write. Now I'm going to start with cos. Remember, I started with sine. I said sine A cos B. Now on the right side of positive, I'm going to start with cos. Obviously, it's going to be cos. It can't be cos of B. I have to use a different angle. So it's going to be cos of A times, obviously, I'm going for sine, is going to be sine of B. So I have expanded the compound angles of sine. Sine A cos B plus cos A sine B. So we are going to do the same with sine 30 plus 45. So I'm going to have sine of 30. Remember, I said we start with sine, then we go to cos. Cos 45 plus, now we are going to start with cos, but we use a different angle. So it's going to be cos of, it was cos of 45, now it's cos of 30 times sine of 45 all over. We are now going to expand the compound angles of cos. What you guys need to know is that if you have got something like cos of A plus B, this is going to be expanding compound angle of cos. It's very, very simple. Expanding the compound angles of cos, it's very simple. Why am I saying that? Because we are just going to say cos, cos. Let me write it so that you can see it. You say cos of angle A, cos of a different angle. If it's A here, obviously now it's going to be cos of angle A, cos of angle B. Now, very important, the sign should change. Your sign here, it's positive. If you observe the sign in the bracket, it's positive. So when we are expanding cos, the sign will change. We are going to now use a different sign. Now we set cos A cos B. We're going to continue with the same idea, but now you are using sine. So you're going to say sine A, sine B. So let us expand cos 30 plus 45. It's going to be, obviously, it's going to be cos of 30 times cos of 45. The sign should change. You see the sign here, it's positive. So it should be negative. You do the same. Sine of 30, sine of 45. Oops, it's not that visible. Sine 45 there. Now, let me continue here. On my numerator, I know that sine of 30, this sine of 30, it's 1 over 2. So I'm going to say 1 over 2 times, you can even press your calculator and say sine of 30 is going to give you 1 over 2. Let me see if I do this. You just press, even though they said solve it without a calculator, since they don't see you, you can press your calculator, guys. Oh, what did I do? I messed up my investigation. It's here, and then my calculator, it's here. I wanted to pull this cashew somewhere. Yes. Let me say sine of 30. What's happening? Sine of 30. You press it on your calculator. Sine of 30. You say equals to, it's 1 over 2. 0.5, it's 1 over 2. This is writing in a decimal form. Yes, it's 1 over 2. So even though they say don't use a calculator, since they don't see you, press it, guys. Press it. Press that calculator. Now you are going to cos 45. I know that cos of 45, it's 1 over root of 2. So you say 1 over root of 2. This cos 45 plus, but now you'll notice that when you press cos of 45 on your calculator, you are not going to get 1 over root of 2. Yeah, let me press it here. Cos of 45 okay, on your calculator for sure you're going to get square root of 2 over 2. Press it on your calculator. This one, I think it is already expressed to be in a decimal form. It's something that I will need to change. I want my workings to be in the fraction. So cos of 45, when you press it on your calculator, is going to be the square root of, 1 over square root of 2. When you press it on your calculator, it's square root of 2 over 2. And we know that the square root of 2 over 2, it's 1 over square root of 2. Let me show you why I'm saying that. So we are having, I'm saying if you press cos 45 on your calculator, you're going to have square root of 2 over 2. We can rationalize this square root of 2 over 2. We can say square root of 2 over 2, multiply the numerator by the square root of 2, and also multiply your denominator by the square root of 2. So now when you multiply these two fractions, square root of 2 times square root of 2 is 2 over, then you're going to say 2 times square root of 2, which is 2 square root of 2. This, you are left with 1 on top. So you've got 1 over square root of 2. This is cos 45 plus cos 30, which you just press your calculator. Cos 30. Let's press the calculator. Cos 30. Guys, you'll press your calculator. I've lost my calculator here. I don't see my calculator. Please, you'll press your calculator, guys. When you press cos 30 on your calculator, it's going to be square root of 3 over 2 times sine 45, it's 1 over square root of 2. All divide by cos 30, or we said square root of 3 over 2. Times, we are on the denominator now. Cos 45, it's 1 over square root of 2. Square root of 2 over 2, it's 1 over square root of 2, guys. Minus sine 30, you are just pressing your calculator. 1 over 2 times sine 45, it's 1 over square root of 2. So now I'm going to go to the numerator and multiply these two guys. 1 over 2 times 1 over square root of 2. So I'm going to multiply the numerators together. 1 times 1, it's 1 over 2 times square root of 2 is 2 square root of 2 plus, now I'm going to look at this one, square root of 3 over 2 times 1 over square root of 2. I'm going to multiply the numerators together. Square root of 3 times 1. Square root of 3 times 1, it's square root of 3. 2 times square root of 2, I'm multiplying the denominators, is 2 square root of 2. All over, now I'm going to work on the denominator, this one. Multiply the numerators together. Square root of 3 times 1 is square root of 3 over 2 times square root of 2. I'm focusing on the denominator, is 2 square root of 2. Minus, let me look at this one. So I'm going to multiply these two fractions, 1 over 2 times 1 over square root of 2. So let's multiply the numerators together. So we've got 1 times 1 over denominator. You're going to multiply 2 with the square root of 2. So you've got 2 square root of 2. Okay. So now, guys, let's go back to the numerators. Let's work on the top part. This part. So we're going to have, we added the numerators. So we're going to have 1 plus root of 3. So it's going to be 1 plus root of 3 all over 2 root 2. I just want to write this division. This one, I want to write it here as division. Then let me go to this one. Let me work on the numerator. So I'm going to have square root of 3 minus 1 all over. Remember, the denominator is the same here. So I'm going to say square root of 3 minus 1 over 2 square root of 2. Now I'm going to have, as we continue, let me erase. Now I'm going to have 1 plus root 3 over 2 root 2. I'm going to change this division here into multiplication. But as long as I'm changing the division into multiplication, I have to invert this fraction. This fraction. I have to do something to it. So I'm going to say 2 over root 2. The denominator becomes the numerator. 2 over root 2. The numerator becomes the denominator. Square root of 3 minus 1. Now this, cancel this. We are left with 1 plus root 3 over root 3 minus 1. So I'm not sure if they will give you 4 marks up to this one, up to this answer that I've reached here. 1 plus root 3 over square root of 3 minus 1. But I know we can try to maybe try to rationalize further. There are a lot of things that we can do from here. But if you reach this point, guys, I'm happy. 1 plus root 3 over square root of 3 minus 1. If you reach this point, that's it. I think you will have shown a lot of mathematical skill, even though I want to continue further from here. Let me not be lazy. Let me take it further and see where can it lead us to. This 1 plus square root of 3 over square root of 3 minus 1. 1 plus square root of 3 over square root of 3 minus 1. So I will try to multiply by 1 minus square root of 3 over 1 minus square root of 3. I doubt they want you to continue further. I'm using, you see here it's positive. So I'm multiplying with 1 minus root of 3. I'm using the negative sign here. So the numerator is what we call the difference of two squares. If you multiply 1 plus root 3 times 1 minus root 3, you're going to realize that your final answer is negative 2 over, this one is going to be, if you use FOIL method, it's going to be square root of 3 minus 3 Square root of 3 minus square root of 3 minus 3, and then minus 1 plus 3, which is negative 2 over square root of 3. What did I do? Square root of 3 minus 3 minus 1. Oh, it should be plus square root of 3. So you're going to have 2 square root of 3, 2 square root of 3 minus 4, which can be seen as minus 1 over root of 3 minus 2, something like this. So, but just end here, guys. Just end with 1 plus root of 3 over square root of 3 minus 1. Other things you will learn as time goes on. Thank you so much. Hopefully, 4.1 and 4.2 of your investigation was very useful to you guys. I will see you next time. From me, all the best.